Welcome to this week's homework, a description and analysis of the use of the bar model or tape diagram. Please remember that this representation is a picture that shows the connections between the different amounts in a story. Then once you understand the relationships between the amounts in the story, well, then you can figure out what operations you need to use in order to solve the problem. For this homework, I would suggest that you read the story problem and then stop the video. Go ahead then and draw what you think would be a representation of the story in a bar model. Go ahead and use the operations to solve the problem. Then when you are ready to check your work, restart the video and you can check your drawing with mine as well as your calculations. Now remember that our drawings may not look exactly alike, and that would be okay if your drawing is accurate and useful. So check for that. Is it useful? Is it accurate? If so, then it can stay as it is. Check your work against mine. If you make a mistake, have an error, please correct that mistake and error on your sheet of paper. Then you will turn this paper in to me on Thursday. So that will be your homework paper that you will turn in. Okay, off we go with the first problem. Okay, the first problem says a 5-meter long ribbon was cut into 3 pieces. If one piece was 1 2/5 meters long, and the second piece was 1 1/3 meters long, find the length of the third piece. All right, now here is where you'll want to stop the video and go ahead and draw a bar model that would represent the story, find your solution, and then restart the video when you're ready to check your work. Okay, when I read the story, I realize that we've got one quantity. In other words, one pile of stuff. So we have the 5-meter long ribbon. So I'm going to go ahead and draw one bar model. And this is my 5-meter long ribbon. So 5 meters. From here to here. And then it said it was cut into 3 pieces. If one piece was 1 2/5 meters long, I'm going to go ahead and split it. And this is going to be 1 2/5 meter. And the second piece was 1 1/3 meters long. So maybe not quite as big. 1 1/3 meters long. Then the question is, how long is that third piece? All right, this is one of those problems when I have a part, and I want to know the third part. So the first thing I've got to do is find out, well, what is this part? So I'm going to take my 1 2/5 and the 1 1/3 and add those together to find out what that part is. So I'll get a common denominator of 15. 3 times 5 is 15. 3 times 2 is 6. And 1. And 5 times 3 is 15. And 5 times 1 is 5. So now I add those two together, and I have 2 11/15. So now I know that this part was 2 11/15. So now I've got to figure out if this is part here is 2 11/15. What is this second part? Well, that's just a part whole problem. So I'm going to take the 5 meters as my whole, and I'm going to subtract this part, which is 2 11/15. 15ths to find the missing part. Don't have any 15ths yet, so I'm going to decompose that 5 into 4 and 15 15ths. And this 2 and 11 15ths stays the same. 4 minus 2 is 2, and 15 minus 11 is 4, and those 4 pieces are 15ths. So now I know that the length of the third piece is 2 and 4 15ths meters. Okay, have I answered the question? Find the length of the third piece. Yep, all done. Very good. Okay, here is your second problem. Since you're all good readers, I will let you read that yourself. You'll want to stop the video here and then work on your sheet of paper. Draw your bar model representation and then solve this problem. Okay, good luck to you. Okay, let's take a look at the possible bar model drawing for this and the solution. When I look at this problem, I notice that we have two separate quantities. We have what Caitlin biked, and then we have what Sarah biked. Although Sarah's amount is connected to what Caitlin biked, because it said Sarah biked 2.5 kilometers further. So I am going to go ahead and put in two separate quantities though. I have Caitlin's, and then I have Sarah's. Sarah with an H. So it says Caitlin biked 10 4/5 kilometers. So I'll draw the bar for Caitlin. Here's her 10 4/5 kilometer. And then Sarah biked 2.5 kilometers further than Caitlin. So she biked the same amount that Caitlin did. I'm just doing a little dotted line to represent the same amount. However, Sarah went further. In fact, she went 2 1/2 kilometers further. So because this part is the same as Caitlin's, I know that this is 10 4/5. And then the question is, how far did the two girls bike? So I want to know all together, what did the two girls bike? Now the question doesn't ask me to find out exactly what Sarah biked, so I really do not have to find the answer to how far Sarah biked. I've just got to find out the total. So I'm going to add 10 4/5 plus 10 4/5. So that's Caitlin's part and the part that Sarah biked that was the same as Caitlin's, but we know that we have that 2.5 that Sarah biked further than Caitlin. I'll just add all those together. I'm going to use a common denominator of 10. Now because I'm adding, I'm leaving that whole number alone. So 2 times 5 is 10 and 2 times 4 is 8. No problem. This is easy. I just write down the same amount. 8/10, 10 8/10. And then the last one, of course, 2.5 is the same size as 2 5/10. So that would be 22 kilometers, and then the fractions would be 8, and 8 is 16, and 5 more is 21 tenths. And I notice that my 21 tenths is actually greater than 1, so I'm going to simplify that. There are actually 2 holes inside that 21. So that would mean that the distance was 24 1/10 kilometer. Now just to refresh your minds, remember to turn that fraction greater than 1, 21 tenths, into a mixed number. It's 21 pieces, and we want to know how many groups of 10 that we can make with those 21 pieces. It would be 10 tenths. And of course, that's 2 groups of 10 with 1/10 left over. So that's how I changed my 22 into 24 and 1/10 kilometer. Okay, so all together, the girls traveled 24 and 1/10 kilometers. Okay, here is problem number 3. Again, I'll let you read it. Stop the video and do your drawing of the representation, then solve the problem, and then come back and check your work. Okay. As I read this problem, I am picturing one pile of cards. They're really all Davis's cards that he shared with Varun. So I'm going to go ahead and create one bar. This represents Davis's cards. Now it says he gave Varun 1/3 of his cards. I'm going to estimate where 1/3 is, somewhere right in there. So I know that this was 1/3. And then it says after he gave away that 1/3, he had 84 cards left over. So I know whatever was left, it was a total of 84 cards. And then what I want to know is, what is my whole? How many cards did he have before giving away that third? Okay, so this is a part whole problem. I know the part of 84, and I've got to find out how many cards were in that third. So if I could figure out what is in 1/3, then I can solve the problem. Well, I know that if this part is 1/3 of the whole, then this part must be 2/3, because I know that 3/3 makes the whole. So I will take that 2/3, and I can even think of splitting it into 1/3 and 1/3. So to do that, I would take the 84 and split it into 2 equal parts so that each part has 42. So that means there's 42 cards in each third. There are 3/3 and a whole, so all I really have to do is say there are 3 groups of 42, which is equal to 126 cards. So David's had 126 cards in the beginning. Okie doke. Good job. Okay, we're ready for the 4th problem. I will tell you, be patient with this one. Draw it out first and then look at your drawing, at the pieces that you have left, the amount you have left, and then see if you can go ahead and figure out how much that amount was that she spent on her jacket. Okay, I'll be quiet now, stop the tape, and go ahead, draw the representation, and see if you can find the solution to this one. Off you go. Okay, in this story, we have one quantity, and that is Billy's monthly allowance. So I'm going to draw one bar that will represent all of her allowance. So it says in the story, I'm going to put a 1 up here because that represents her one amount of her allowance. I don't know quite what that amount is yet. But it says that she spent 7/12 of her monthly allowance on a jacket. So I'm going to go a little bit over a half. And this is 7/12. And she spent that amount on a jacket. Now, if this part is 7/12, and I know that one whole is 12/12, then this part must be 5/12 of that whole. Okay? Now it says of that remainder that she had left, she used 3/5 of it on a new video game. So I'm going to take this 5/12 and actually go ahead and draw it out. So that's 1, 2, 3, 4, 5. Sorry, my proportions are a little off, but it is 5/12 of what was left. And it said of that five pieces, she used 3 of them, 1, 2, 3 of them on a video game. And she ended up with 2 of those 5 left over, and it says those 2 represented $24. Okay, so I'm going to pause for just a minute there and let you take a look at that drawing and see if you agree with it. We have her whole allowance. We can split it into 12ths, and we know that 7 of these 12 piece parts were spent on a jacket. We know that there were 5 pieces left after that, 5/12 left after it, and she spent 3 of those 5 pieces, or 3 out of 5, 3/5 of what was left on a video game. She had 2 of those pieces, or 2 of the 5 left, and that was $24. So at that point, if 2 of these pieces are $24, then I know that 1 of these pieces is $12. So if I think about my whole, if this remaining part is 5/12, then I can say 1 of those pieces, or 1 of those 12ths, is equal to $12. And if 1/12, 1 of the 12 pieces is equal to $12, and she spent 7 of those pieces on a jacket, then 7 times $12 is equal to $84. So she spent $84 on the jacket. I'm curious to see how you drew this problem. I'm anxious to hear the different solutions that you came up with, but hopefully you came up with the solution that she spent $84 for the jacket. Okay. Okay, we're ready for the next problem. This problem is similar to the previous problem in that you're going to be thinking about remaining money. And you also have to think about, well, how are you going to represent 1/6 of that remaining money? Okay, go ahead and stop the video. Draw the representation, the bar model representation for this story, solve it, and then you can check your drawing and compare it to mine. Off you go. Okay, when we look at this story, we realize that we have one quantity, and that's Emily's money. So I'm going to draw one bar that represents Emily's money. It's one amount, and I don't know what that amount is yet, but I'm considering that as my one whole. The story says that she spent 1/3 of her money on a dog. So I'm going to go ahead and try to split this amount into 3 equal parts. And I know that 1/3 of this part was spent on a dog. Sounds like a fun purchase, Emily. The next part of the story says that Emily spent 1/6 of her remaining money on a belt. So I've got to look at this 2/3 that's left, this remaining money, which would be 2/3 of the whole, and split it into 6. So here's one part, 2 parts, 3 parts, 4 parts, 5 parts, 6 parts. So now I've got that leftover 2/3, that leftover part, and I've split it into 6 equal parts. And it says one of those parts was spent on a belt. All right, so Emily has 5 of these parts left over. 5/6 of what was left after she bought the dog is left over, and we know the story tells us that that was $35. So $35 was from here to here. So the $35 can be equally split into 1, 2, 3, 4, 5 equal parts. So let's go ahead and do that. $35 split into 5 equal parts, that's dollars, would give me $7 in each part. So I know that there's $7 here, $7 here, $7 here. Now, that's kind of interesting because these 3 parts represent 1/3 of my whole, right? So 1/3 of that whole is actually $21. So if I know 1/3 represents $21, then I know, and I also know that it takes 1, 2, 3/3 to make the whole, then I just have to say 3 times $21. 3 groups of those $21 would give me the total amount of money that Emily had. So Emily had $63 before she went on the spending spree and bought some cool stuff. All right. Okay, good job. Persevere. Stay with this. Okay, this is our last problem for the homework for this week. It is similar to the last 2 problems in that we're taking a look at what was remaining, and then you have to think about how are you going to represent 5/9 of the cookies that were remaining. Okay, off you go. Please draw your bar model representation, solve the problem, and then you can turn the video back on and compare your solution to mine. Okay, let's draw Summer's one quantity or one amount of cookies. So that is Summer's one whole amount of cookies. We don't know how many cookies those are. In fact, that's really what we're trying to find out, is exactly how many cookies there are. Now, when we go back to the story, it says her friends got 2/5 of them. So that's where we'll start this story. So here's 1/5. Here's 2/5. Here's 3/5. Here's 4/5, and there's 5/5. Again, sorry, my drawing proportions are a little bit off, but we can still work with it. It says that her friends got 2/5. So let's go ahead and take out the 2/5 that the friends got. And then the story says that her family got 5/9 of the remaining cookies. So the 3/5 that are left, I've got to split them into 9ths. So that would be 1 part, 2 parts, 3 parts, 4 parts, 5 parts, 6 parts, 7 parts, 8 parts, parts, 9 parts. So we took the 3/5 that was left over and split them into 9 equal parts. And then the story says that her family got 5 of those 9s. So that's 2, 3, 4, 5 of those 9s, and that's what her family got. All right, then the story tells us that she had 32 cookies left. So these 4 parts that were left, this is what's left, represent 32 cookies. So 32 is actually split into 4 equal parts, which means there are 8 cookies in each one of those parts. So I can think about this part being 8, this part is 8 cookies, and this part is 8 cookies. Now I'm going to stop for a minute because I've hit that 1/5 of my whole amount. So this is telling me that in 1/5 I have 3 parts with 8 in each part, so I have 3 groups of 8 cookies, which is 24 cookies. So this is 24 cookies. This has another 24 cookies. This is 24 cookies. Here's 24 cookies, and then here are 24 cookies. So there's 5 groups of 24 cookies. And that, of course, is equal to 120 cookies. So Miss Summer had 120 cookies in the beginning. Okay, I hope it started to make sense to you and you were starting to reason a little more strongly. Make sure that you turn this paper in to me or come see me at school if you have questions.